MathKlik.
Mabuhay! What is a quadratic function? How are quadratic functions represented? How do we determine whether a relation is quadratic function or not? This lesson is about defining quadratic function. Not all relations can be represented using linear models. Some can be modeled using curved graphs. Here are some examples. The flight path or trajectory of a ball shot from a distance to a goal follows a function of time. The cable support of suspension bridges have traces of quadratic models. The area of a rectangle can be expressed as a quadratic function of one of its sides. These physical relations have one thing in common. They can be modeled by the so-called quadratic function. A quadratic function f is defined by f of x is equal to ax squared plus bx plus c, where a, b, and c are real numbers and a is not equal to 0. The equation f of x is equal to ax squared plus bx plus c is referred to as the standard form of quadratic function. The standard form f of x is equal to ax squared plus bx plus c can be transformed to another useful form of quadratic function. Let us use the method of completing the square in deriving the so-called vertex form of the quadratic function. Regroup the first two terms of the quadratic function in standard form, then factor out the coefficient a. This will give us a quantity x squared plus b over ax plus c. Produce a PST by adding and subtracting the square of 1/2 of b over a. This will yield a quantity x squared plus b over ax plus b squared over 4a squared plus c minus b squared over 4a. Factor the PST x squared plus b over ax plus b squared over 4a squared and combine c and b squared over 4a. This will result to a quantity x squared plus b over 2a quantity squared plus quantity 4ac minus b squared all over 4a. Finally, rename negative b over 2a as h and 4ac minus b squared over 4a as k. This is the vertex form of the quadratic function. Let's do this exercise. Transform f of x is equal to x squared plus 2x plus 1 in vertex form. First, we identify the coefficients. A is equal to 1, b is equal to 2, and c is equal to 1. Compute for the value of h. You can do this by substituting the coefficients to the equation h is equal to negative b over 2a. The value of h is equal to negative 1. Now compute for the value of k by substituting the coefficients to the equation k is equal to 4ac minus b squared all over 4a. The value of k is 0. Using these values, form an equation using the vertex form f of x is equal to a quantity x minus h squared plus k. Therefore, the vertex form of the quadratic function f of x is equal to x squared plus 2x plus 1 is f of x quantity x plus 1 squared. If a relation is expressed as a set of ordered pairs or as a table of values, you can determine whether the given relation is a quadratic function or not. Observe how the second difference test is applied in this example. Let's examine if the given relation f of x is a quadratic function or not. Let's separately investigate the behavior of the x and the y coordinates. The difference between any two consecutive x coordinates is -3. The corresponding difference in x does not produce equal first difference in y, but the second differences in y are all equal to 2. This phenomenon is true to all quadratic functions, and this can be used to identify whether a relation expressed in ordered pairs or in tables is quadratic or not. Let's formalize it. A relation f is a quadratic function if equal differences in the independent variable x produce non-zero equal second differences in the function value f of x. This is the so-called second difference test. Let's solve this. Determine whether the relation expressed in the table below is a quadratic function or not. Remember, for a relation to be a quadratic function, one of the conditions is that the common second difference should be non-zero. First, test if there is equal differences in the independent variable x. Indeed, equal differences of 1 in x's exist. Then, find the differences in the dependent variable f of x. Finally, test if there is equal non-zero second difference in f of x. Note that there is a common second difference in f of x, but the difference is 0. Hence, the relation expressed in the given table is not a quadratic function. A third way of recognizing a quadratic function is through its graph. Its details will be presented in the next video. Watch for it. Now, try this. Transform g of x is equal to 6x squared plus 5x minus 6 in vertex form. Then, identify h and k. The vertex form of g of x is equal to 6x squared plus 5x minus 6 is g of x is equal to 6 quantity x plus 5 over 12 quantity squared minus 119 over 144. H is equal to negative 5 over 12 and k is equal to negative 119 over 144. Use the second difference test to determine whether the set of ordered pairs g of x is a quadratic function or not. Since equal differences in x produce equal second differences in g of x, then g of x is a quadratic function. For more matitinik tips, just click MathKlik. And please, don't forget to subscribe and click the notification bell for our next video lesson. See ya!